the
iPhone?
Yeah, the iPhone side of it. So like when we launch our app right now, you know, we do the 6S and the 38 millimeter, and the app launches, and all we care about is the Apple Watch screen. But we have a second simulator that's sitting there with just a white screen on it. So we see this like, oh, we're happy, it's running, blah blah blah. But at the end of the day, there's a second simulator screen out here that's our watch app. Actually, there should be something that has launched on this. I wonder if it hasn't finished launching yet. That's interesting. So this is that app. That's just a white screen. And that app is managed by this guy up here that we hit a while, not that guy, this guy here that we hit a while ago. So this is that storyboard for a iPhone app that's going to use a lot of the same stuff as we had before, but notice we have a lot more widgets that we can put on there. But let's just throw a label out here to prove that that is the case.
So is the code functioning, is it running on the iPhone or is it running on the watch?
It's running on the watch with Apple Watch 2. But you can't have an Apple Watch. You have to. As far as I can tell, you have to.
Like, as long as, like, if you were running the process on the iPhone, that'd make sense why, but.
See, this is actually kind of interesting because I just updated that label. And it doesn't seem, see, I have the app on my watch, and then I also have it on my phone. There was no way for me to not get it installed on my phone. Let me do this.
I wonder if it has something to do with handoff in terms of it having or needing to have that link to the iPhone in case there's something that needs handed off either via Siri being active in the application or something else.
Do you have it just saying label, or did you change the text inside the label?
I just have it saying label right now.
Then it might not be showing up because you just threw a label up there and didn't assign anything.
That should show up. I mean, the default text should be there. I want to start off by getting this thing zoomed. Alright. And then for right now, let's kill our simulators and let it relaunch. And go right there. Yeah, I mean, this is text, so that should show up. That label there. Let's do a clean. Yeah, so right now we're looking at the Dice Roller Watch Kit app. Which should be running on the 6S and the 38 millimeter. Okay, so we'll launch that. This should give us both of our simulators. It's interesting. When the app is there, let's delete the app off the phone. Alright, well, regardless of that, it's back now. How do I get this guy to stop shaking? Shouldn't it give me a home button down there? Yeah, there's label. Oh, that's the problem. Is I'm currently in a. I like to use.
Size of the view controller, yeah.
Drag it like that, so now it'll show up pretty easily. But seeing as though there isn't an option to not have the app show up, as the developers, we have to always have, it seems like to me, we have to always have a plan for that application that lives on the phone, right? Because everybody's going to get it. I couldn't find a way. I went into the application here and I was trying to find a way to essentially say I don't want the iPhone side of it. In my mind, I don't know if I see a huge need for every application to have an iPhone app as well as a watch app.
Especially in terms of like the small little widget apps we're making.
And why doesn't this? There we go.
Couldn't you have it set so that the phone keeps all of the recent rules?
Oh, you certainly could. I mean, we could certainly force a reason for having the watch app, or the phone app version of our watch. What I'm more interested in is there a way to turn it off? So here's our project. When I go to, is it under info, build settings maybe? Maybe it's under targets, general. Yeah, so deployment info, it shows me that this is for the, actually let's go here. This is for the
Under the main dice roll, I wonder where it says deployment for iPhone, can you just switch? Is there an option there for just the watch?
You mean where? This guy?
Yeah.
No, I mean it's
Oh, I see.
iPad or Universal, which is
Oh.
this is the normal screen for a
Okay, just
for any iPhone application, way prior to watch. So this guy seems to be dumb to the existence of a watch. So it really seems like this guy, the extension, and really, I mean, it almost makes sense that this is the way it should work. Is this extension thing? By definition, you're extending an iPhone app. So seems like we can't turn it off, which I don't know. There seems like there should be some reasons to turn it off.
Does because of the limited capabilities of the watch in terms of its memory and CPU, doesn't it make more sense for us in the case of like storing, hash rolls or something like that on the iPhone because it has more power?
Oh, potentially, but I don't think we should have to.
Yeah.
Do you know how much the watch depends on the phone? Do you know what I mean? Like,
Significantly less so in Watch in WatchOS 2 than WatchOS 1. It can operate. Like most of this app is running on just the watch. Well, actually, our entire app that we've written so far is running on just the watch. And we know that's the case because we haven't written any stuff on the iPhone side of it. I guess what kind of bugs me about it, though, is we can certainly come up with reasons to have the watch be an extension of the iPhone app. I mean, a good example is like Slack. I get all the Slack messages on my watch, but I don't really use my watch to talk on Slack. I just, somebody messages me, I want to say something back, I go onto the phone and I say it back. You can reply, but it's actually fairly inconvenient. On the watch, they need to redesign their notification thing to allow me to reply right there rather than go into the actual app. But in our situation here, we have an app that I think we could argue that the app is lightweight enough, and what we're trying to do with it doesn't require that there's an iPhone component to it. I think we could fairly make that suggestion. Yet I can't figure out how to turn off the iPhone side of it, and I think it has to do with how a WatchKit app works.
Supposedly, WatchKit apps are now completely native in OS 2.
Correct.
But they're still forcing you to bundle it with an iPhone app.
Correct.
It's supposed to be changing.
Okay, so
There's no good reason.
all right,
Other
so
than
so as of right now, we're stuck with it, but that's okay for us because we want to learn how to make those two talk. Because, like we just said, there is a reason. There may be reasons where we write apps that we want the two to talk. that we want to have both. So let's start off by going in here and what are we currently storing in our singleton? Because right now, here's our singleton. We have our num sides and stuff like that. Actually, let's do this. Let's see if these guys share NS user defaults. Because we are using NS user defaults right now inside of our awake with context, right? Yeah, here's our defaults. And then we're going through and we're grabbing the dice strings. We're displaying them to the screen. Let's try this. I'm going to start off by just copying this code here from our watch app, and we're going to go in and we're going to start doing some stuff on the phone app side of things. So we're going to go into view controller, which is equivalent to our interface controller.swift, kind of that main screen for that came with our first interface for Apple Watch. Same thing's true here. When I go to main storyboard and we click on this first guy, he is of type view controller. All right, so a lot of the stuff we know about the watch translates over to the phone as well. So I'll go into the view controller here, and instead of awake with context, we have something called view did load. So this is our first point in the ecosystem, the life cycle of an iPhone application where we can do stuff with the app. So we'll come into view did load here, and let's just try to grab those preferences.
That's going every time the view is loaded, or just the first time?
It's exactly the same it's exactly like awake with context. So it's called every single time this particular view controller is loaded, not before it shows up. Every time it's loaded. So one time ever per run of the application. Okay, so we'll take a couple of these extra functions out, and let's just do a print S here. So we know we already have some stuff showing up inside of our application, so let's go ahead and grab our NS user defaults, and let's do a little print here. In phone app. So hopefully the phone app is sharing the same NS user defaults as the other guys, so these two are working with each other. So here in the phone app, in view did load, we'll go ahead and grab the NS user defaults, get our array, the dice strings, and just go through and spit them all out so we can prove that we have access to them in the phone app as well as the watch app, and let's see what happens there. Actually, we currently don't have any roles in here. Did we reset it? Must have reset
You
it.
did it clean, so yeah.
No, the cleaning the software doesn't change NS user defaults on the simulator.
I think it would.
Mm-mm. So at some point in there, I must have. We'll add one more. I must have reset the data on the attack. 65D20. That is a attack. All right. So let's go now into dice roller. There's our label. Let's actually run this one more time. I wonder why nothing is printing there. Let's run a different target instead of the Apple Watch thing. Okay, so that popped up in phone app. Okay, so right off the bat, we just got hit with the first part of bad news. The first bad news here is, okay, so a couple things we just figured out here is if we just want to run our WatchKit app, we run this target. All right, and so it seems like David was pointing out, that The watch is the mechanism by which a phone app is launched, but as we've been seeing, that phone or the phone app doesn't automatically launch when we're testing the watch app. So if we want to test the phone side of things, we click on this other target. Okay, so we have 3 different targets to work with here. We can look at the phone app. We can look at the watch extension, this guy right here, which is our main watch interface. We can look at the notification screen associated with the watch, and if we had chosen the other ones, the complications and stuff like that, we would have other targets here. But right now we have 3 targets. We've never touched the notification one. This would be like if the phone app is going to send a notification to the watch, we can have something pop up. We need to get them communicating first. But right off the bat, we got the news that when we run our phone version of the app, Dice Roller here, and it launches, we see here that it says that we're inside of the phone app. So we're seeing this print statement right here, fire. But immediately before that, we are grabbing from NS user defaults the dice strings, which we know exists on the watch side of things. So if I go back over to the watch and I launch this guy, make sure I got the right, yep, that's fine. We'll see that we have our 2 rolls that it's remembered. So we know that the dice strings has stuff in it. Okay, there's our 2 rolls, except I click something. Right, there's our 2 rolls, 64 and 65 D20. So we know for a fact that the dice strings in NS user defaults has a value inside of here. In Awake with Context on our main interface controller on the watch, this NS user defaults has a variable called the dice strings that has stuff in it. Over here in our view controller on the phone side of things, we tried to grab the same exact variable. There's nothing in there. Okay, so these guys are not sharing user defaults with each other. All right, so we need to figure out is how do we get the phone and the watch to talk to each other? Okay, how do they share information? So let's look at the Apple Watch 2.0 transition guide. Okay. All right, so here's kind of our picture for what's changed. So in Watch 2, the way things are communicating is this way. In Watch 1, it was this way. So in let's see, in Watch. Okay, so on the iPhone side of things, in Watch 2, the extension lives specifically on the watch. So this is things running natively on the watch. In Watch 1, the extension actually ran on the phone and then kind of streamed to the watch. So that's why things were more sluggish. So we're living in this world up here. All right, so that's why our app can seemingly run in its entirety on the watch without us putting any logic in the phone side, because none of the watch logic is over here. But that isn't to say that we don't also want to have an iPhone app. So if we scroll down a little bit here, they tell us some of the mechanisms. Well, they kind of give you some of the choices as to whether or not you want to migrate, but we've already done that, so that ship has sailed. Let's see. Okay, so let's see. Most of your WatchKit extensions code should continue to work in Watch 2.0, but moving the WatchKit extensions to the user's watch has implications in how you design your app. You must implement your extension using the framework in the watchOS SDK instead of the iOS SDK. Fair enough. All right, so that's why we had interface controllers, those native things that are watch specific. Let's see, for any features not available in the watchOS framework, so for instance, view controllers and a whole bunch of other stuff, we have to rely on the phone app to perform those corresponding tasks. So we've kind of seen the things that exist in watchOS SDK, and we can look at those, but punchline is there's definitely less in there than there is on the phone. Phone knows how to do these 50 things, watch knows how to do these 6, something like that. All right, so we've done everything in terms of what can happen on the watch right now. So your extension now stores files and data on the Apple Watch. Fair enough. So that's kind of lending us, kind of supporting what David's saying about. It certainly makes sense for us to be able to have a watch app that lives completely independent of the phone. So any data that is not part of your watch app or WatchKit extension bundle must be fetched from the network or from the companion iOS app. So we need to figure out, we'll do the network stuff next. How do we store stuff in the cloud and bring it down to both? But now how do we make these two apps talk directly to each other? So anything we're going to store or show in the iPhone app, we need to be able to send between the watch app and the iPhone app. Let's see. You cannot rely on a shared group container to exchange files with your iOS app. Fetching files involves transferring them wirelessly to Apple Watch, and I'm guessing vice versa, because we want to get stuff back into our watch. All right, so let's see. This is open parent. Communicating with your companion iOS app. It's like, how do you get a pet? All right. To communicate with your WatchKit extension and iOS app, use the Watch Connectivity Framework. That framework provides bidirectional communication between the two processes and lets you transfer data and files in the foreground or background. The framework replaces the existing open parent application method of the WK interface controller class. All right, with the Watch Connectivity Framework, you use WCSession. I wonder what WC stands for. Yeah. Yeah, so they like some intern wrote the class. It's like
Connectivity one.
oh, star for the day.
Well, it's just watch connectivity framework, so I'm assuming.
Oh yeah, I'm certain that you're right. All right, you use the WCSession object to initiate transfers and to manage connection between your WatchKit extension and the iOS app. You configure and create the session object early in the launch cycle of your app, with the idea being that if you want there to be communication between these two on a constant basis, it needs to happen, on your interface starting off over here, as well as in your view did load over on the phone side, so these guys are communicating early on. So that's what it's talking about, happening early in the launch cycle of your app. Activating the session lets Watch Connectivity know that you are ready to send, receive messages from the other app. Let's see. All right, so here's some Swift examples. All right, so we can ask the question here if WCSession is supported. So you might have an if statement like this in your application if you have kind of two versions of your app. You're transitioning from WatchKit or WatchOS 1 to WatchOS 2. So WCSession is only available in WatchKit 2 for WatchOS 2. All right, so if this is supported, what are we going to do? We're going to go ahead and let our session equal WCSession.default session. So this seems like it's kind of like NS user defaults, something related to that. And then we're going to set our session delegate to self. So this would be inside of, I'm guessing, our watch application at this point, but I'm assuming we can do the same thing inside of the other one. But by having our interface controller presumably being the delegate, that's what self would be here, having our interface controller being the delegate for this session, there's going to be a callback function that probably gets called anytime information is available. So hopefully we'll see that here shortly. Let's go ahead and just grab this code real quick and let's drop it into our, let's get rid of this for a few minutes. I'm going to dump this stuff on the phone side of things. Just out of curiosity, I'm actually going to paste this in here. I just want to know if that will build. Okay. Yeah, it doesn't know about this on the phone side of things. So this WCSession said two-way communication, so maybe it'll let us know here in a second. So let's try to drop this inside of our main screen IC inside of Awake with Context. So we'll just do this right here at the top. Oh, he doesn't know about that guy either. Okay. WCSession. Do we have to import something? WCSession is a normal plain Jane NS object. Okay, well, this is the delegate stuff. So we've kind of dealt with this with our table view, where we have, whenever somebody clicks on something in the table view, we can respond to that event, did select row from table view or whatever it was called. So it looks like there are 4 different delegate methods for this guy. One is update application context, given an error. Another one is send a message. Another one's transfer user info, and the other one is transfer file with metadata. So I'm guessing it's just those 4. Let's look at WCSession delegate here and see if that is consistent with what they're saying. Let's see. So managing state changes. So here's a method in the, so notice these are all Watch OS 2.0 stuff, and this is the delegate method. So these are all the functions that will get called whenever events occur in terms of communication between the phone and the watch. So one of them is session reachability did change. So my guess is that this happens when the watch goes offline, Bluetooth is turned off, something like that. So no longer is this session a shared session. So as I'm interpreting this right now, think of this word session, as we're seeing, as a little walkie-talkie that sits between our watch and our phone, and this is the thing that these guys use to communicate with each other. So if the availability of our signal changes, this guy gets called. Receiving context data, so this is sending information back and forth between the two. And we've already seen in our Apple Watch only app that context information is kind of our way to send stuff between multiple screens in our app in like a simplistic way, not using the singleton, but using, here's one interface controller, here's another interface controller, here's a piece of information I want you to know about. So here's our way of knowing when we did receive something from the other guy. All right, so what David was talking about at the beginning of class was this idea of the observer model. So this is kind of the built-in type thing where this function will only get called when the other guy, this is assuming that these life cycles live on both sides, this guy will only get called when the other guy sends a message here. All right, so if Yenter is the phone and I'm the watch, whenever he sends me a message somehow, which is probably going to be one of these guys down here, this guy will pop up that I did receive something. Okay, that'll be my my wake-up call to let me know I need to go and do something. All right, and they're calling that context data specifically. Immediate messages, so did receive message with a reply handler. So that would be a closure. So a callback function that should get called when we're going to reply. Did receive message data with a reply handler. Okay, so kind of same thing. I'm guessing these first 2 are for text messages. The second 2 are probably for files. Here's file transfer specifically. So maybe this is strings and this is other. Yeah, we'll see. Data dictionary transfers. So user info must be the data dictionary that they're talking about. So it's probably similar to NS user defaults. And then file transfers. So in any case, here's all the functions that belong to that delegate and we can implement. None of them say required, so we don't have to write any of them. But logic would say that you wouldn't create a WC session unless you intended to have some level of communication between the phone and the watch. Okay, but as a delegate goes, none of these are required. Therefore, we don't have to write them, but we should probably write them. Okay, so let's bounce back here and let's see if we can put this into context for where do we put these in our, well, actually our first problem is how do we get our app to know what WCSession is? Let's start off with this real quick. WCSession, okay, it doesn't know about that. So let's just look this up real quick. Unresolved identifier WCSession. There's probably a library we need to import that. Unresolved, was that symbol? Identifier. Okay.
Oh, is it just as simple as changing the target on the watch side to have the phone as well included, so it has access?
Let's see. Well, I would think it would be that way by default. You know, that main interface that we're working with up in the phone, the view controller, is the original one that came with our original interface controller. So you would think this would be set up by default. Let's see. That doesn't seem to... import watch connectivity. All right, so import watch connectivity, and now, so that's in our main screen, and then awake with context. Okay, yep, we're okay here. So this guy, the error message, so now it knows about WCSession. So this guy is saying that you cannot assign self. So our self right here is going to be an instance of main screen IC, which is an interface controller, right? A WK interface controller. But what we just need to do is we need to implement, let's see, what is the... Well, it's WC delegate. But what's the, is it this? Let's see. Swift delegate implementation. So Swift protocols. Yeah, here it is. Colon, no. Some class colon. Okay, there we go. So it's colon WC.
No, it's comma. It's like main screen IC colon WK interface controller comma.
What? Oh, I understand what you're saying. What was this? WC session delegate. All right, so this guy now knows about that, which means now that self, now that we have this guy saying he implements that session delegate, now self will be one of those, so that should stop screaming about that line down here. So it's cool with this line now, because self is no longer just a main screen IC, it's now also a WC session, blah, blah, blah. All right, so let's import watch connectivity over on the phone side now as well. Make sure it's cool with that over there. Seems to be. And then we're going to also go ahead and have this guy implement the same delegate stuff. So this is WC session delegate. Okay, fair enough. And then we're going to go ahead and throw the code in here. because it is a two-way street. So let's steal it back from in here. So we'll have the phone go ahead and grab onto this session so it has access to it. So we're doing it as early as we can on the watch, awake with context. And we're doing it as early as we can on the phone, view did load. All right, so now it's happy enough with those things. Okay, so now we want to go ahead and start implementing some of the session delegate methods. I wonder if there's a way for me to automatically do that. I thought there used to be, or should be. No, doesn't seem like it. Or if there is, it's not obvious. So we need to go and write some of those methods. Let's go back to the documentation here. Here is our this guy, and we need our delegate protocol. So let's look at did receive message. So this is a optional function from session. We get the session and we did receive a message from the session. So we're going to have one guy try to send a message, the other guy try to receive a message, and let's see what happens. So let's have our phone receive the message right now. So inside the phone, I'm going to go ahead and paste that function in there. All right. This guy is a protocol member. Oh, that's not how it's defined though. So we're implementing that optional method in here. It's optional in the protocol, not in here. All right, so like a few minutes ago, I was mentioning that protocols, which from like your Java perspective are called interfaces in Java. So kind of like a class, but it just defines a list of things that you must implement or should implement, let's say. They're called protocols in Swift, and if you don't put the word optional in front, they're required. You have to implement them. And let me kind of show you that example real quick with UI table view data source. UI table view data source. This is on the phone side of things. So here's a protocol. And we should see that several of these, so here's two that are required, self, a row, and index path, and number of rows and section. So let's look at number of sections in table view. This guy is optional. But if we go to self, a row, and index path, notice that this guy is not optional. Okay? So if you don't put optional in front of it, those functions will be required for anybody who says that they're implementing that protocol. They will have to write them. But since we saw inside of the session delegate here that none of these functions actually say required after them, as we scroll down, let's just look at just Swift. None of these guys actually say required after them, so they will all be optional. So if we want to, we can say, hi, I will participate in the WCSession delegate protocol, but I literally have implemented none of the methods, therefore I'm impossible to communicate with. That's allowed. Makes no sense, but it's allowed. Kind of makes sense what we're kind of dealing with here? All right, so now, as we currently have it, our phone will be notified through this protocol that when he did receive a message, and we'll actually get the message as an array. So this is an array of it's a tuple, I guess, right? A key and a name. That's going to be the message. So we can just go ahead and print message here. Should look reasonably okay in some sort of readable format. All right, so did receive message. We'll go ahead and print the message out. And then we need to go and send the message on the other side. So let's go ahead and on the watch, let's try it at the very beginning. So we just got our session. We activated the session. Can we say session dot send message? Well, I want to do this simple one. Wasn't there one that didn't require us to do a handler? Guess not. All right, so the message we're going to send. I got to have a reply handler and a. I thought we saw there was a better one, or a different one at least. Oh, Nick, send emoji. All right.
That means I can send goats. And then if the other emoji is the middle finger, it will be like sending goats to get.
Okay, so this was WCSession send message example. Let's
Make it a butcher now. Sending goats to the butcher.
Yeah, so we saw the instantaneous thing.
Is it was 2 or 1?
It has to be 1 because WC session only exists in 2. Before that, it was that you had the shared group thing, which you could put a singleton in. So to me, seemed easier, but we'll see once this works.
Do you need a reply handler and error handler, or they just like?
Well, I assume you can set them to nil. Let's see if they give us an example of how we can have one guy send a message to the other guy. Because we're sending a tuple across there. All right, here we go. Session, send message. That's here. We're creating some application data. We're giving it a counter value and then the string version of a counter. So this is like the key. So I guess let's just steal this real quick. Just start off by seeing it happen. All right, so we're going to send a counter value over there, and let's just, it wants it as a string. So we're just going to say 5. Okay. All right, so we're going to pass the number 5 over there, or the string 5, I suppose. And then we're going to say session, send message, application data. Here's our reply handler, and this guy's upset about something right now. Well, the reply handler, I thought hold on a second, session.send message. Should look like this. We'll say application data. Then reply handler look like that, and then that. And then we'll do nothing right now. Then error handler look like that, then that. Do nothing again. Oh, so the same error we have below. If you're not going to name a parameter, they want you to put this underscore thing underneath it. So this is the reply handler taking in no parameters, or requiring a string any object parameter. So let's just call this the reply, in case we decide we want to play with that. So in this case, this guy was expecting a to list. I guess this is a tuple in Swift, which we haven't messed with yet, but we'll see it here. So kind of a single entry from a dictionary, name value pair, but just sending a single one of those rather than a collection of name value pairs. So by default, this guy didn't give us the name of that variable, so I just went ahead and named it the reply, and it comes in here. So this is handle the reply from the iPhone app here, in case the iPhone app wants to send something back. Because where is the iPhone app going to get this? So this is the watch sending a message to the iPhone app. The iPhone app then receives the message here, did receive a message, and let's see, WCSession. Oh, there was a couple of versions of this, weren't there? There was a Funk session did receive message with reply handler. Yeah, this was that second version of this guy. We'll just say do nothing right now. So there's two versions of this in this protocol. One, we can receive a message and do nothing. We don't have the ability to reply to it. The other one is we can receive a message and we can reply to it. And let's find out which one we get into actually here. Print with reply handler. I actually think we're going to get into both. I think both of these guys will get called. And without reply handler, and then we'll print out the message in both of them. And let's see which of these, if either or if both, we get into. All right, so as we have it set up right now, both of these guys take part in our WCSession for communicating between the watch and the phone. They both register with it. That's up here. So the phone does it in view did load. This is where they connect. The watch does it in activate with context. So right at the beginning for both of them. Then the watch tries to send a message to the phone. I'm not sure if we'll be able to do it in the activity because there might be, or the activate with context. So there might be a timing issue where these two haven't already joined the context or something. So we'll see. We might have to attach it to a button. That's what the example had done. But in any case, assuming the communication can happen, what should happen now is on the phone, we've implemented two of those protocol methods. Both of these are did receive a message. So we'll see which of these get called or if both of them get called. And then on the phone side of, or the watch side of things rather, we're sending a message right here. So we're through our session, we're sending a message. What message are we sending? The message counter value equals 5, essentially. Passing it the reply handler in the event that the phone decides to reply to us in case we're asking the phone a question and then I'm sending something back. Which is why I thought we should be able to send a message without that, but I guess we'll see that here in a second. So let's go ahead and try to send this message from the watch to the phone and see if the phone can receive it. That's the punchline. So we're going to start the watch up. Yeah, this might actually be difficult to test. Okay, so the watch has sent the message now. I need to go here. Let's open up the dice roller. So that guy's currently running, so he's man, is this even testable in the simulator? It's the issue. Because both of these guys need to be aware at the same time. And does the simulator allow me to run both?
I'm sure it has to somehow. It'd be stupid not to be
Yeah.
able to. But then again, it's Apple, so I
Could you set the label to display the message?
Well, we could. That's not the issue. Right now, the issue is that they're not both running at the same time. The simulator, we can either launch our Apple Watch app or we can launch our iPhone app, but we can't launch both of those apps. And the way we have it set up right now is both of those apps are running, I guess, independently of each other. So I think what we'll have to do next time is we'll have to associate what I was saying before, an IB action with a button, so that we can stage it. We get the phone app up, we get the watch app up, and then once everything's good, then we hit the button and hopefully the message arrives over here. So we'll start off with that next time, but it seems like we're stumbling down the path of how that communication occurs between the two.